Good afternoon, everyone. All right, so in this session, we will be continuing looking at matrices. So we know that when it comes to matrices, you could add them, you could divide them, you could multiply them by another matrix or a scalar quantity. Now we're going to look at matrices with respect to their inverse. Now, a matrix could be singular, right? So you could have singular matrices. Or a matrix, right? So a singular matrix means that there's no inverse. Or a matrix could be a non-singular matrix, meaning that it has an inverse. Right, so it could be singular or non-singular. If it is non-singular, it simply means that there is an inverse. Now we're going to look at what is the inverse of a matrix. But in order to be able to find the inverse of a matrix, we're going to have to learn the determinant of a matrix. Right, so we're going to look at the determinant of a matrix. Now, a determinant of a matrix, they'll either tell you find the determinant, or they might give you a symbol like this. So let's say they gave you a matrix A, and it said matrix A, whatever is a matrix, it's in the form of A, B, C, D. So we're looking at 2 by 2 matrices. In order to find the determinant, you're going to find the product. Now, I like to see it as an X. When I write the letter X, I always write this strand first. So I call this my leading strand. And then this one, I'll call it my other strand. So my leading strand, I'm going to find the product of those two. So it's going to be A times D. And I'm going to minus the product of the other strand. So that's going to be BC. Now, once you find this, this is known as the determinant of the matrix. All right, so when it comes to the inverse, so in order for us to find the inverse of a matrix, we're going to need the determinant. Now, the inverse of a matrix it's represented, right? So if you're given a matrix A is equal to A, B, C, D, or whatever 2 by 2 matrix you're given, replace it with the letters A, B, C, D. In order to find the inverse, which is represented by whatever letter the matrix is, so this negative power of 1, this represents the inverse of a matrix. So it's going to be 1 over the determinant multiplied by, we're going to change these two, the position of these two, we're going to swap it. So where I have A output D, and where I have D output A, and the other two, I'm going to change the sign of them. So if it was positive, it becomes negative. And if it was negative, it becomes positive. So basically, this is the formula that we need to know to find the inverse of a matrix. Right? So you have A inverse, instead of having this, remember this here is the determinant. So you could replace it with 1 over AD minus BC times the swap of the leading strand and then the change of the sign of the other two elements. So we have to learn, you can either learn this one or this one. Now, we know that we cannot divide a number by 0. If you do it, you're going to get an error, or we call it what is known as undefined. Even if you try it on a calculator, it's going to show you that it's an error. Now, what happens if AD minus BC is 0? What happens if this is 0? If this is equal to 0, right, which is the determinant. So if the determinant is equal to 0, there is no inverse. Right, so there will not be an inverse. As a result, if there's no inverse, it is what we call a singular matrix. Right, so if there's no inverse, it exists on its own. So we call it a singular matrix. All right, so we're going to look at solving simultaneous equations using the matrix method. Basically, a simultaneous equation is an equation where we are trying to find two unknowns in the same working. Now, in terms of your matrices, we are going to generate matrices to show this information. So what we do first is you write the coefficients. A coefficient is the number that is in front of a letter. So we write the coefficients of each of them in the form of the matrix in the same order in which they are. Remember, you have to put in if it's positive or negative. So my first coefficient of A was 4. Coefficient of B is positive 5. Of this A is 3. And of this one, it's negative 5. Then you're going to take out the variables, which is the letters, and you're putting it in the order that they are. So A was first, so you're going to put that on top. B was second, so you put that below. And then you write your solutions in the form of a matrix. Now, I know you guys will be wondering, how did we get from this to this? And what I'm going to do is I'm going to show you how I'm going to move back from this to this. So do you remember when we were multiplying matrices? It was always each row by each column. So it was first times the first plus the second times the second. So first times the first plus the second times the second. And once you finish with that one, it's going to be the next row by the column. So you're going first times the first plus the second times the second. So this becomes 3A minus, because we have two different signs coming together, the 5B. So this is what we have here. So when I multiply this back out, I'll get back this. All right, so we know how to work that one. Now, what we can do is we could label this matrix A. Now, I'm trying to find these two. So because we're trying to find it, I could label that X. And this is another matrix with some values, so I could label it as B. So with the matrices, I have AX is equal to matrix B. Now, I want to find out the value of X. Now, the X, if I'm trying to find the X, we know normally in algebra, you carry across the others until you get the unknown alone. And once you cross the equal sign, you perform the opposite. So if I have matrix A, the opposite would be the inverse of matrix A. Now we normally put it after what was there before, but in matrix A, the case of the matrices, we're going to put it in before it. So what we want to do is, in order to find X, I'm going to multiply matrix A, the inverse of matrix A, by B. So the first thing I need to do is to find out what is the inverse of A. So remember, A was 4, 5, 3, negative 5. And we're trying to find the inverse. Now, what we can do is in this, label your matrices A, B, C, D. In order to find the inverse, remember, it's 1 over the determinant. 5, we're going to swap the leading pair and change the sign of the other two. So that becomes the determinant, which is AD minus BC. I'm going to multiply these two. So this becomes minus 5 times 4. 5 4s are 20, so that's minus 20. Then multiply the other two. So 5 3s, that's 15. So in this case, we have minus 20 minus 15. Once you have two same signs, you add and keep the sign. So it becomes minus 35. So my determinant is going to be negative 35. So what we'll do is that we're going to have 1 over the determinant, which is negative 35. And then, right, so this is to find the inverse of the matrix. So we're going to swap these two. So where I had D, I'll put A, and where I had A, I'll put D. And then I have to change the sign of the other two. So if it was positive, it becomes negative. And if it was negative, it becomes positive. All right. So the next step, remember this is A inverse. All of this is A inverse. But they asked us to multiply A inverse by B. Now, what I like to do is anytime I have a fraction in front of here, I prefer to work the matrix times the B, and then I'll multiply by the fraction. If it is that this becomes like a whole number, you just multiply it. Or if it's like -1 or so on, you just multiply by everything inside. But as a fraction, you could focus on the matrices first and then multiply it by the fraction last, as you did with the scalar multiplication. Right? So it's going to be -5, -5, -3, and 4. And I'm multiplying it by B, which is 12, 9. So I'm going to multiply the matrix first. So remember, I'm just putting this here so I don't forget it. So I'm going to multiply. Remember, it's each row by each column. First times the first. Plus the second times the second. Then when you finish with that one, you're going next row by the column. And you're going first times the first. Plus the second times the second. You could do a check because once you are correct, the numbers after the multiplication sign will be the same both top and bottom. And then the ones in front of the multiplication sign will be a replica of this first matrix. So -5, -5, -3, 4, -5, -5, -3, 4. Right? So you could do that check if you get it. If it doesn't line up with that, then you have to check it over. So I'm going to work out. Remember, these I'm working out, and these I'm working out independently. But math tells us multiply before we add or subtract. So this one will be -5 times 12 right? You could use a calculator there to speed it up. So 5 times 12, that's -60. Then -5 times 9. 5 nines are 45, so it's -45 here. Here will be 3 times 12, that's negative 36. And then 4 times 9, that's 36. In this case, this becomes minus right? So this becomes minus. So this becomes negative 60 minus 45. Right? So for this one, I'm bringing back down the negative 1 over 35. Right? So this becomes, once you have two different signs, you add and keep the sign. So negative 105. And then this one here becomes negative 36 plus 36, that will be 0. So in this case, I could now multiply whatever is outside by everything inside of it. So I'll have 135, right? So 1 over 35 times negative 105. So this becomes, on top would be negative 105 over negative 35. Because when I multiply this by this, I'll get 105 over 35. And anything multiplied by 0 is 0. So this becomes 105 divided by 35. That becomes positive 3. And then you have 0 below. Now, that means that x is equal to 3, 0. Now, remember, x was actually the matrix AB. So you're going to get AB is equal to 3, 0. And anytime you have matrices which are equal, we know that elements in the same position will be equal to each other. So A is in the same position as 3, so A is 3. And B is in the same position as 0, so B is 0. Right, so my solution would be A is 3 and B is 0. So this is my answer. Now, what I like to do, and it's because simultaneous equations, you could always leave knowing whether you got it correct or not. That's a good thing about simultaneous equations. You know if it's right or if it's wrong. So what you could do is you could check your answers by putting it back into this. So wherever I have A, I'll put 3. So you have, and wherever you have B, you could put 0. So 4 3s are 12, plus 5 times 0 is 0. 12 plus 0 is 12. So you know it worked out there. For the next one, 3 times 3, that's 9. 5 zeros are 0. 9 take away 0 is 9. So you know that your values are correct. So just to recap, simultaneous equations and matrices, you pull it out into the form of matrices. Take out the numbers. You're putting it in the same order in which you removed it, with the sign and everything in front. Then your variables will go, whichever one is first would go on top, whichever one is the second will go below, and then your solution. So you have that AX is equal to B. I want to get X alone, so you carry across the matrix A. So when you carry it across, it becomes A inverse. You have to find the inverse of A, which is where you have to follow the formula. So it's going to be 1 over the determinant. You have to learn how to find the determinant as AD minus BC. One way I used to remember it is like in history, we used to learn dates as in after that or before Christ, right? So that's how I remembered AD, A with D, and B with C. So you find out what's the determinant, and then you're going to multiply it by, you're going to swap these two, right? So of the original, of course, swap their positions, the A and the B, and you change the sign of the other two. So you end up with a fraction, or sometimes this might be like 1 or -1. And then you have to multiply by whatever was this matrix. If I have a fraction, we could multiply the two matrices first. And once you do, then you could multiply by the fraction performing scalar multiplication, where you multiply whatever it is outside by everything inside. Once you do so, you get your solutions. And you could always check it back by substituting the values of A and B into each of them separately. So you do the first one. If you substitute it and you work it out and you get the answer for both, you know that you are correct. If it's not, you just go back through your steps and see where you probably made an error. It's actually really easy to pick up once you follow through the steps. All right, so thank you for watching.